In this topic, we have covered what we mean by ethics. We have covered in the previous slides as well. Ethics for teachers and students, and why it is important, because whatever you are doing in the class is supposed to prepare you for your field, for your profession. So ethics in engineering covers all these different aspects. We have talked about uh, where you may be your ethics may be tested. Okay, some situations in which it may be tested. Okay, and the difference between being showing good manners and being nice and being ethical, so they are not the same. This was the main message here. And engineering students should be looking at the future of the society as well. Okay, I believe we covered this part as well. Some examples were given. Okay, uh, so ethical responsibility, the course can guide you about it, and but you still have to use your judgment. Okay, again some examples. And the ethics is a bigger responsibility, because you have to think about sustainability as well, which belongs to future generations. Okay, ethics plays a good part when you are working in teams, and this is where I said I couldn't give you an example of synergy last time. So synergy means that when you combine a lot of people together, if you combine two people together, then their output is not equal to two people. Their output is equal to three or four people. So I said I will give you an example for that. So let's say you have uh, a wall which has a specific area, and if you hire one person to do the job for the entire wall, that person will take let's say 16 hours. Okay, so they're the worker which can finish the entire wall in 16 hours. Okay, and there's another one, uh, or let's say they're the worker who can do 10 square meters of the wall in 8 hours, and there's another worker which can do 20 or 15 square meters of wall in 8 hours. Okay, now you have uh, 20 square meters of the wall to be done. Okay, so total is 20, and you hire these two people. Okay, so if one of them finishes his 10 square meters in 8 hours in one day, and the other guy finishes the other 10 square meters in his 8 hours, so they are both working simultaneously, so you'll finish 20 square meters in one day in 8 hours. Okay, normal working time for a day is 8 hours, right? So one guy finishes in 10 square meters, the other guy finishes also 10 square meters, and both of them are taking uh, exactly 8 hours. Okay, this is not synergy. This is just combining work from different people. Okay, this is not synergy. Now, if you look at one of the guys, he can finish at 15 square meters in 8 hours basically. Okay, so when one of the guys, he is doing his 10 square meters, he requires full 8 hours, he requires a whole day. The other guy, he will finish his 10 square meters not in 8 hours, he will finish in 6 hours. Okay, now there are few things he can do with the extra 2 hours. Okay, so can somebody tell me from you, what should he do in those extra 2 hours that he has? Okay, his speed was faster, the other guy is still working, he is free. Okay, and you know that when the other guy finishes, the work will be done. Now what this guy should do, should he just wait for the other guy to finish and they, sorry, he should help the other guy, right? So so if he helps the other guy, he reviews his work. Very good. He can review his work, yes. or he can help the other guy. That's another possibility. Okay. Now in both cases, or he takes rest, right? Okay. That okay. I worked faster. I have 2 hours extra. I should rest. Why should I, you know, uh, waste my time with something else? Okay. So if he decides to rest, the whole for work finishes in 8 hours for the other guy. So the entire wall of 20 square meters finishes in 8 hours. Okay, nobody is doing anything for anybody. This is not synergy. If he tries to help the other guy, maybe both of them will finish in 7 hours. Okay, because now this guy is helping. So instead of needing 1 extra hour, now this guy may need, oh sorry, instead of needing 2 extra hours, this guy may need only 1 extra hour. Okay, so this will be called as synergy. So you will still finish the whole job, but not in 8 hours with two people, but in 7 hours. Okay, and the extra hour you can do the review thing as well. Okay, and the review thing will help the next team member, the team member who is supposed to review your work. So you can tell him, or he will need less time to review your work. So you can spend the remaining 1 hour in reviewing your work. So the next guy who is supposed to review your work for payment, uh, he will have less problem, or he will have to see less things. Okay, so this will be called synergy. Okay, that you finish the job earlier, you also help the other member, and so on and so forth. Okay, so synergy means that the stronger members try to support the weaker members, and they try to uh, do the job faster, okay, by supporting the weaker members. So they are not just looking at their work, they are looking at the other work as well, and the result would be that the entire work will be done faster and easier, and so on and so forth. So it will be faster for everybody, not for this only one guy. Okay, so this is the whole idea of synergy. Okay, so we already went through this slide as well. The weaknesses we normally see in the group work, and most of them are related to communication, by the way, if you have noticed or not, but whatever we discussed were related to communication. So you have to be very flexible and open in communication, and communication is two ways. Communication is a two-way thing. Okay, some of them are related to listening carefully as well, listening to others' ideas, and you know, listening means you have listen with respect. Yes, this guy can be correct as well. Okay, the next thing which is related to ethical responsibility is showing leadership and accountability. So the first thing you have to notice, or first thing you have to note down, is it's not related to the title. Okay, because we are talking about ethics. So it's not that you see something is going wrong and you don't do anything about it because you are not the manager or you are not the boss. This is unethical. Okay, ignoring something wrong, or not doing something correct just because you are not responsible is unethical. Okay, and I already emphasized a lot of times that in engineering this can cost you lives. Okay, if you let go of something like this. So leadership and accountability means that you are taking responsibility for your decisions and actions. Okay, even if you are under pressure, and I already gave you some examples of how you can be under pressure. Okay, you don't like the other guy, you had already a fight with him or her, or something like this. Okay, so in those cases, so for example, you did something on the site, and because of that thing an accident happened. Okay, now people come and ask, okay, who should we blame for? Now you see, this is a difficult situation. Something has already gone wrong. Okay, something has already gone wrong. So leadership and accountability means you will still take responsibility of your actions, And if you are not a good leader, if you're not an ethical person, an ethical professional, you will try to blame others. Okay, in this case, obviously, if everything is going correct, okay, then there's a saying, I will write it here, that success has many fathers, but failure has none. Okay, so you may have heard about it. Everything is going correct, everybody is praising your team. Oh, you did a wonderful job, your project was so good, okay, everything went well. Then nobody will shy away from the responsibility. Nobody will say, okay, I didn't do anything. Okay, but what if something goes wrong? Okay, and it was your responsibility. Will you still go ahead and take it? Okay, and in some cases, you are not the manager, let's say. I'm emphasizing it because this is what happens. Okay, the blame goes completely to the manager because he is the official guy. But the manager was not doing everything himself. The boss, the site engineer, he was not doing everything himself. Okay, so and he is a or she is a human being. So he or me she may have missed something which has went wrong, which has resulted in an accident. So yes, officially he gets or she gets the responsibility. She is or he is blamed for it. But the point is, let's say that that thing was related to form work. Okay, so the form was not installed properly, and when concreting happened, it fell down on somebody. He got or she got injured. Okay, yes, the manager should have checked it, and he may have missed a spot, or she may have missed a spot, and from that mistake this happened. So yes, it is partial responsibility. But what about the guy who was actually doing it? Okay, uh, does he get the share of responsibility or not? Okay, that's the question. Yes, somebody has to check my work because he's my boss. But does it mean I should not do it properly? I should only wait for him to tell me that something has went wrong? No, whatever is my job, I will do it properly. Okay, so we have mentioned this point earlier as well. We don't be ethical because somebody is watching over us. Okay, so ethics is not if nobody said anything, I'm good. No. Okay, ethics is doing your job properly till the end. Okay, and this is where the leadership and accountability comes into play as well. Okay, you are a leader and you are accountable for whatever amount of work you have done, whatever amount of work is given to you. And in a project, nobody is useless. Somebody has given you a job. Okay, even if it is only lifting bricks from one point and taking it to the other point, this is your job. Okay, if you don't have any job, if you don't have any work, then you will be jobless, obviously. Okay, you are in the team for something, right? So that thing, you are the leader of that thing, you are accountable for that thing. Okay, so somebody could be the leader of the entire team, the entire project, and he officially gets the responsibility in the end if something something goes wrong. But that doesn't mean the others are relaxed. The others do not have any responsibility. No, they have responsibility for their own job. Okay, so before the responsibility of the manager to check them, this is their own responsibility to check themselves. Okay, so a lot of people do their job in a very relaxed manner. Okay, and they say, okay, my manager will check it, and if he doesn't like it or she doesn't like it, they will tell me, and I will correct it. But until that, I don't need to pay attention because somebody will already check me. No, this mentality is wrong. Okay, because you are relying on one person to look at the job for everybody. He's not looking at your job only. A project site may have 15 other people, so he's looking at everybody. Okay, so and if you rely on one guy to look at check everybody's work, he's bound to make more mistakes. So everybody has to do their job properly. This is my point. Okay, and the job title is just for the others to look at, okay, who is responsible, but within the project, within the team, you should not be looking at it like this. Okay, uh, so if something happens, you see an issue. Yes, so another thing is taking leadership and accountability. Something is going wrong. Okay, nobody has asked you about it. Okay, so something went wrong with the form work. Now concreting is about to happen. Okay, you did the form work, there's an issue, you can see the issue, but now you see the concrete mixture is there and the concreting is about to happen. Okay, so nobody has seen that issue yet. So should we, the manager is not telling you anything. Okay, he is going on with the concreting. Should you let it happen, or should you stop it? Okay, so the point is you should stop it because you have seen the issue. Okay, so a good leader, a person who is ethical, who is accountable, will, when he or she notices their mistake, they will try to correct it, or at least try that nothing goes because of that, nothing goes bad because of that. Okay, so this is again, the point is leadership and accountability in ethics is not because what others are telling you, it's because what you are doing. Okay, so leadership is shown through honesty, accountability, and courage. Okay, to make difficult decisions. So these are difficult decisions which I told you. Okay, taking responsibility for an accident, stopping the work because of an issue when nobody else has seen it. They are difficult decisions. Okay, difficult situations. So if you are still showing courage to take difficult decisions in those situations, you are a true leader. Okay, I gave a definition for what do we mean by accountable. Okay, and I gave it when we were doing the physical classes. So somebody remembers accountability means what do we mean by accountable? I've already explained what do we mean by it, but uh, I gave a specific definition for it. Being accountable means what? Yes, anyone? What do we mean by being accountable? Ready for questions? Okay, good enough. Yes, yes. Being ready for questions. So you have done something, you have taken a decision, and you are ready if somebody asks you, that you have a reason to show them that why you have done this. Okay, good. Okay, so why leadership is important for engineering, like as a professional, why it is important? Because when you are showing leadership, and I told you leadership means that you are taking responsibility of your own actions. Okay, not no, I have to boss around everybody. This is not leadership. Okay, this is a false idea of leadership. Bossing around is not leadership. Okay, taking responsibility is leadership. So when people know that if this guy is doing the work, he will be responsible and accountable. Something goes wrong, he will take responsibility. If something can be improved, he will do it. Nobody has to explain to him. Nobody has to be a watchman over him so that he can do his job properly. There are people like this, right? You have to like continuously stand over their head so that they can do the job properly. But if you are doing it yourself, everything properly yourself, then you earn the trust of your client, you earn the trust of your boss. So eventually we will go up the ladder. Okay, people will know this is a responsible guy, he is a leader. If they have to assign somebody in a management position, they have to promote someone, they will look for somebody like this. Okay, so you earn their trust, and you will get more business, better job opportunities, and so on and so forth. Okay, then we have the professional responsibility as well. That is also part of ethics. So your professional responsibility is towards multiple entities. first of all, the first and foremost is public. Okay, and we have already discussed a number of cases in which your decision can affect people. You are designing a road, designing a building, designing a water treatment plant, you are doing soil work or whatever. Okay, so all these things, they affect public because people are going to use it. Okay, so you have to act responsibly towards the public. Okay, will it do any danger, harm to the public? You have to be responsible towards your employer, towards your boss, your organization, your own organization. Okay, so you cannot do something uh, which will be harmful for your organization. Like you cannot uh, for example, you try to overspend from the budget of the project. This will harm the client later, but it will also harm your organization as well. Okay, or you in your team, you are going to one guy and saying, yo, this guy is not doing proper work and so on. So you are creating a negative environment in your team. Not this is not acting responsibly. Okay, uh, not doing your job properly will also harm your employer and so on and so forth. And responsibility towards client. Okay, client or public can be the same. A client or public can be different. For a road, the client is Ministry of Works, and the public is public who will use the road. Okay, for a building, they could be same. Okay, for a villa, the client and public could be the same. The person who is building the villa, who is giving the money to build the villa, will eventually use it. So the client and the public could be same, or they could be different. If they are same, then they are same, obviously. But if they are different, then the client may have some extra demands from you. Okay, so and so you have to think about those demands as well. Okay, so you have to design the road, you have to for example dispose of the material somewhere. Okay, so when the road is designed properly and is constructed properly, you are fulfilling the public part. But now the client says the material which you are disposing, I want to recycle it and use it somewhere else. Okay, so you will fulfill that job responsibly as well. You will not say, no, no, my duty was only towards the public and so on. Okay, and yeah, another example of client and public. So you are building a villa. Okay, so the person who gave you the money is going to use the villa. Okay, so you don't have to think anybody else in these terms. But what about the people who are living around that villa? What about the people who are using that street in which you are constructing the villa? Okay, the client is interested that you construct the villa as fast as possible. But that doesn't mean you work full night and disturb all the neighbors. Okay, that doesn't mean you bring all your material and all your equipment on the site and block the entire street. Okay, so you are acting responsibly towards the client, but you are not acting responsibly towards the public. Okay, so this is another aspect I forgot to mention it earlier. Okay, and you have to act responsibly towards your profession as well. Okay, so there are some professional responsibilities on you, which are normally given in your job description. That as an engineer you are responsible for this. Your organization will tell you. Okay, you have signed an agreement with the client, so that agreement lists your responsibilities. Okay, when you are supposed to do the testing, and when you are supposed to report how much budget, how much time. Okay, safety precautions. Okay, so these are like written responsibilities. So these are your responsibilities towards your profession. You have to fulfill the obligations which are given to you. Okay, and that can be done from the client side or from your own employer side. Okay, so responsibility is more than being correct. Okay, being technically correct. Okay, and I gave you the examples of the road and the construction of the villa. You are technically correct, you are building the villa as fast as possible, but you are not acting professionally. Okay, so as we have mentioned it earlier, that your decisions can uh, affect human safety, health, and well-being. Okay, human safety, for example, if you do not design the road properly, you may have accidents. So you are endangering human safety. Your road does not have accidents, but you did not design according to the demand. Okay, so people are having traffic jams. So you are now playing with the well-being. Okay, so well-being means the quality of life, the quality of life. Okay, the health aspect. You are using cement on the site, but you are not providing gloves to the labor. You are not providing them masks when they are moving the material. Okay, so they are inhaling the dust, and the cement uh, is damaging their hands and so on and so forth. Okay, so this is related to health, so you have to look at all these things. Okay, so this is the thing. Safety, health and well-being of people, human safety or human aspects, uh, is is commonly found in all code of ethics, in all professional codes. This is one thing, public safety and welfare, which you will find in all professional codes. Okay, so this is something which is non-negotiable, something which is accepted worldwide. Nobody is saying that you should do it in Bahrain but not in Saudi, or you should do it in Gulf but not in Europe. Okay, so there's nothing like this. Then we have professional integrity. Professional integrity means that you are honest, you are fair, and you are transparent. Okay, so you don't hide anything, you don't say lies. Okay, and when you are treating others, you are not differentiating them on the basis of color or race or nationality, or because of your relationships and so on and so forth. Okay, so you are fair to everybody. Okay, so if there are 5 people in my team, okay, I will listen to everybody if they have something to say, and I will give everybody the same chance which the others are getting. This is fair. Okay, or if I'm looking at 3 4 different projects, then I will treat each project with the same importance. This is also uh, this is also what we mean by being fair. Okay, transparent means you have to report properly, honestly. You don't hide anything. Okay, so there's something happened on the site, and an accident happened, material was wasted, whatever. So you don't try to hide it. Okay, and more than hiding, you try to falsify the information. You give false information to the client. This is even a bigger crime than hiding. Okay, some people hide because they already controlled the situation, so hiding can be uh, allowed in some cases. Okay, something went wrong on the site. Okay, material was wasted, but you did something else and you covered the loss. Okay, but you don't want to tell the client, because this will destroy the image of your team and of your organization and so on and so forth. Yes, if you did everything and there is nothing left in the end for to tell the client, yes, project completed on time, as per the budget, as per the quality, nothing, no accidents happened, no injuries, no harm to future use, then okay, fine. At least you may hide, you may try to save your image, and this is also part of your responsibility towards your organization. Okay, but somebody asks you, somebody comes and say, okay, I have come to know from this and this guy that this has happened on the site, and you say, no, 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 this didn't happen, this is false, this is a lie. So lying, is bad. I don't have to explain it. Lying is bad. Okay, so lying, hiding things which could be important, and being unfair, they are all against professional integrity. Okay, so so ethics, is connected to everything which you are doing. Okay, to the reports, to the calculations, to the simulations, to the research. Okay, so it's not only about when some accident happened, then we will see what ethical problems we had on the site. No, even if you are just simply writing a progress report to your client, you have to keep ethics in your mind even in that case as well. Okay, so this is also part of professional integrity. Okay, that you are not waiting for something to go bad. Even the small tasks, the routine tasks, you have to keep your responsibility in your mind. Okay, so already talked about code of ethics. I mentioned in one of the previous slides. So code of ethics gives you a formal set of rules. Okay, so there are rules written, okay, for the professionals, and every profession, every major profession in the world has something like this. Doctors have it, lawyers have it, so engineers also have it. Okay, so a code of ethics is a set of rules which are published by an engineering body. Okay, so obviously the person who is giving you the rule must be an expert, right? Okay, so in this case, the expert is the engineering body, an organization which is related to engineering. Okay, so the important thing is the mentioned in those code of ethics is ethics is not opinion based. Okay, so you don't enforce or select not to enforce ethics because of your own judgment. Okay, ethics, I told you, means being fair. Okay, so you cannot use your own judgment of when to be fair and when not to be fair. Okay, so in this case I will do this, but in this case I will not do this. No, if this is the right thing to do, you will do it in all the situations, whether it will result in something positive for you or negative for you. Okay, or even for the project. Take the example of the public safety. Okay, so public safety is a top priority. Okay, you will not say if I think about safety on this project I will have 10,000 BD extra, so let us ignore public safety. No. Okay, so code of ethics, this is where the code of ethics comes into play, that it gives you the things which you cannot ignore, which you cannot compromise. Okay, so these are written rules. Okay, and so this is what is written here, that public safety is a common feature in all of them. So we don't have one code of ethics, we have multiple of them. Couple of them are mentioned here. Okay, IEEE is mainly for electrical engineers, but because we are using so much AI and electronics even in civil engineering, so there could be some things which we can get from this code of ethics as well. Okay, and this is from US. Okay, if you can download basically the entire code from here. Okay, this is National Society of Professional Engineers. Okay, I believe it's Canadian or American, one of them. Okay, so but this is very famous. Okay, but it's an international code, both of them are international examples. Okay, for Bahraini you may look in the website of Bahrain Society of Engineers, and there's another one as well, CRPEP I believe. So they have, so each region may have their own code of ethics. Okay, so you can see some of them are here, you from UK, from America. Okay, again from UK, these ones I already told you. Okay, this is an academic source. Okay, what else? Yeah. Okay, so this is for your own reading. Okay, now these are code of ethics, not the laws. Okay, so laws are something different and code of ethics is something different. Okay, laws give you minimum acceptable limits for your uh, engineering work. Okay, so laws will give you minimum acceptable standards for your engineering work. Okay, but code of ethics tell you how to do that work. Okay, so the law may tell you that if you are having a villa, then how much you should keep for the open space, how many parking spaces you should have. If you are building a mall, then how many spaces you should have for the disabled. Okay, but ethics will dictate that how you are doing your job. Okay, Yes, and laws take into account ethics as well. For example, laws will take into account the most important part of ethics, which is public safety. You will not find any law which is against public safety. Okay, so uh, but in being ethical means that you don't always follow the law. Like you follow the law, yes, but you don't always stop at this point. Okay, so maybe for example, again I will give the example from roads, that the law says that if you have a pedestrian signal, okay, signal for crossing the road for the people, then the minimum time is this much. But you know, on this road we have a school, okay, so kids may need more time. Okay, or we have a hospital, so there may be sick people who are coming out of the hospital, they need more time, or there may be somebody on the wheelchair. Okay, so the law says minimum time 10 seconds, let's say. But now you are thinking beyond that. Okay, so you are saying, okay, in this situation, I should give more, maybe. Okay, and so on and so forth. So the law may say that if you are using steel structure in Bahrain, these are the standards. But you know, if the structure is sea facing, then the steel may have more losses, greater losses, and faster losses as compared to when the structure is not sea facing. Okay, so should you just stop at the law? No. Then you go ahead and you do something more, which is your ethical and professional responsibility. Okay, and another problem with the law is laws take a lot of time to get approved. So we may face an issue now. For example, we may have what we have now, the rainfall in Bahrain has increased, right? Everybody who has spent some time in Bahrain would agree to that the amount of rainfall we are having has increased in Bahrain. So there could be a change in law related to the drainage on the roads. Okay, you see a lot of roads, they have, rainfall happens and they are underwater. Okay, so the old laws we were having, the old rules and regulations we were having for drainage, they are becoming outdated because the weather is changing. Now, somebody has to change it, but changing the law means you have to get the approvals. First of all, somebody has to say what should be changed and how it should be changed. Somebody has to do some research on it, right? I cannot just wake up one morning and say, okay, the gradient of the road should be changed from 2% to 3%, and that's it. No, why? Okay, I have to make my own reasons. I have to do research. If I do this, will this solve the problem, and so on and so forth. Somebody has to identify the problem, somebody has to give the solution, somebody has to test the solution. Then once this is done, then it will go to different committees, okay, to approve, because the law will be applied to the whole nation. So this will take a lot of time. This may take 6 months, 8 months, 1 year. Okay, during this time you are doing your project. You still don't have the updated law in your hand, but you know that this is a problem. From your experience, you have seen that this problem happens, and it is happening every year. So you just wait for the law to be changed. By that time this project is finished. Okay, but if you know the problem, you can rectify it, you can correct it yourself, okay, on this project. So this is what is the difference. This is the difference between laws and ethics. Okay, laws, yes, they help you to set the minimum standards. Okay, but ethics may require you to go beyond that. Okay, so some examples here. Let's say you are inspecting a very old bridge and you see some cracks in the steel girder, steel slab. Okay, so the engineer who did the inspection, they said we should close the bridge and replace the slab. Obviously, this means that you will have a lot of disturbance to the public and you will have a lot of cost. Okay, so the local authority, somebody in the local authority tells them, no, we cannot face this much, we don't have this much budget, we cannot face public resistance because you will close the project, somebody will complain and so on and so forth. So you should downgrade your inspection report. Don't recommend this in your inspection report. Now the authority themselves are saying it, okay, and it's not against the law. You did the inspection, you can say yes, we'll do it one by one, but it's dangerous. Okay, so the ethics in this case will require you to even go against your client, okay, or against the transportation authority. By law you shouldn't do it, but ethics require you to do it. Okay, so let's say you are a software engineer, okay, and you are hired by the government, okay, and they are asking you that you should design a hacking system so we can see what people are doing on social media or on their messages and so on and so forth, okay. And this is allowed under the laws of the land. The government can have a look at what people are doing, because this is for public safety, because this is for national security, okay. But is this ethically justifiable or not? You have to see, okay. A very popular example, okay, for self-driving cars, driverless cars, okay. So you are programming a decision system for the self-driving car. You are the programmer, okay, and you are, so how they do the programming in these cases, they generate different scenarios, okay, and then they feed into the system. If you are faced with this scenario, this is what you should prioritize, this is what you should do, okay. So let's say one of the scenarios which you have generated is that you have on your left hand side you have a motorcyclist who is wearing a helmet. On your right hand side you have a kid, okay, who is standing on the side of the road, and in front of you you have a barrier or a blockage or whatever, okay. So you are at high speed, and the scenario is you can either go straight and hit the barrier itself, you can go towards the right, or you can go towards the left. In any case there will be damage, okay, you cannot avoid the damage, okay. So which of these scenarios should the car go for? What should be the decision of the car, okay, because the car will take the decision itself, it's driverless car, okay. So in this case there is no guidance provided by the law. The law doesn't say you can hit the kid, or you can hit the motorcyclist, or you can go and hit the barrier. No law would say this, okay. So this is something where you have to make up your own mind, okay. Somebody may say, okay, the motorcyclist has a higher chance, or the car owner should take chance on his life, not somebody else's life. Why hit the kid, or why hit the motorcyclist? You go and hit the barrier and you kill yourself if you want to. Don't kill anybody else, okay. So these are like things which no law can cover, okay. It cannot be covered by law. You have to think on your own terms, okay. So these are some of the examples where the law may not provide you guidance, okay, and you have to make your own judgment, okay. And obviously I'm not giving you a decision right now on which what you should do in each case, but just to start your thinking process, this can happen to you. Okay, continuing on with the same topic, okay. Before we move on, let us do a small activity, okay. And we haven't done on anything on discussion board now, so I'll ask all of you, I'll create a discussion now, and I ask all of you to go to the discussion board and write the answer to this question. What is civil engineering to you in one sentence? one sentence only. Okay, so I will go to the discussion board. Okay, and you give me one sentence about what is civil engineering, all of you. Okay, like I said, we are keeping a record and this will be okay in your own words. You don't have to go and look in the slides. What is civil engineering to you? So I give you like 2 minutes, okay? Just over the top of your head, whatever you can think about. Okay, I don't need a book definition here. I believe I have to make it visible for you, right? Okay, now it should be visible for you. Please go ahead. Just one line, one sentence only. So moving on. So why civil engineering is different from other professions or other engineering? Because we are dealing with things people cannot avoid, like roads. People, a lot of you have mentioned infrastructure. So you cannot avoid infrastructure, right? Here we are getting a lot of uh, threats on the infrastructure, right? People from both sides in the war are threatening that you will destroy your infrastructure, right? So this is like the backbone of the society: roads, bridges, buildings, water systems, and all of these things are built by civil engineers. And when you are driving on the road, you are driving on the bridge, you go inside a building, you are trusting the civil engineer that he or she must have done their job properly, so the building or the road or the water system is safe. When you are taking water from a bottle and you are drinking it, you are trusting the guy who did the treatment, right? So if you break this trust, you will endanger the life of the people. You will waste public resources. Land is a public resource. We use water in construction. We use natural resource in construction. So if your work is not done properly, then all those resources are wasted. Okay, and in some cases, you may affect the entire community. For example, by means of environmental damage. Okay, so you have created a structure that is creating noise pollution. You are not doing the water treatment properly, and that water is getting disposed of in the sea. So you are polluting the entire sea. So this is danger to the entire community. Okay, so a civil engineering mistake is not private mistake. It's not a personal mistake. It becomes a public issue. Okay, so this is a specific definition of civil engineering. You will find others as well. Ethics in civil engineering, sorry. So the ethics in civil engineering means that it's commitment of the engineers to design, build, and manage infrastructure in a way. First thing, which we have been saying again and again, public safety. Okay, serves society. You're doing something for the people. You are solving their problem, making their life better, and so on and so forth. Respects the environment. Okay, so minimum damage to the environment. This is also part of ethics. And you uphold professional honesty and responsibility. I already mentioned it in the previous slides. Okay, even under pressure from cost, time, or authority. So I gave you examples just before 5 minutes ago, in which the authority may ask you to do something, but that has ethical questions. So then you have to check, should I do it or not? Okay, so this is under pressure, and cost and time are always against you, right? You're always trying to save cost. You're always trying to get the things done faster. But uh, in doing so, you may do something which is not good for safety, which is not good for the project, and so on and so forth. For example, using sub-quality material, it will save cost. The material could be cheaper. It could be available, in the local market, but it may not be good for the project. Okay, so in civil engineering, ethics is the responsibility of the engineer, and the same thing which is written, but they are two different. This is another definition for it, a more concise one, but it says the same thing basically. Okay, there are four pillars of ethics in civil engineering: public safety, responsibility to society, environmental stewardship, conservation, and professional integrity. Okay,
Sorry, sir.
so we will go through. I believe we are going through each one of them now. Okay, so I just we have already gone through them. I just want to explain the word here, stewardship. Okay, steward, you have steward in ships, okay, and you have stewards in planes as well. Okay, so stewards are basically the guys who are uh, responsible for that thing. Okay, so steward is somebody who is responsible. Okay, so environmental stewardship means that you consider yourself to be responsible. Okay, so this is what we mean by stewardship, and other things we already discussed earlier. So ethics versus law and versus technical correctness. So law, as we have mentioned earlier, gives you minimum requirement. Technical correctness means that you are following the standards and you are doing the calculations properly. There is no mistake in your calculations. The things which gives you full marks in the exam, right? The technical correctness is what gives you full marks in the exam. Engineering exams, my calculations has no mistake. I followed all the assumptions properly, the equations properly, everything is done, and you are good. Okay, so this is technical correctness. Okay, and laws we already mentioned, and but ethics goes beyond that, and it gives you moral responsibility as well. Yes, the calculations are correct, but if I implement them, what will be its effect on the people? Okay, so this is a scenario now. City hires a firm to design a retaining wall along a busy highway. Okay, what is a retaining wall? If you have seen, if you have gone to Budaya Highway, you have seen the main signal with the roundabout for the highway. अच्छा इनको क्या है उधर का भी खराब है हाँ हाँ और वो पानी भी ब्लॉक हो रहा है
सेम टाइम में गिरता है क्वांटिटी में नहीं गिरेगा जब वो पानी छोड़ेगा ना उससे तुरंत गिरेगा क्योंकि लाइन में पानी होगा ना जैसे छोड़ेगा तो पहले गिरता था इधर जाएगा उसके बाद में आता है
दूसरे में अब्बू गए थे ना
अच्छा चलो बात
हाँ वो भी गए थे ना उनको लगेगा टाइम
अंदर आदमी
हाँ अभी गए हैं
उसके बाद में आएगा
हाँ उसके बाद
और गाड़ी अपना पार्किंग में रखेगा अच्छा
हमारी का आपकी मेरी पार्किंग नहीं हमारी नहीं है वो
नहीं अपना वो साइड आप रखा मुश्किल नहीं है बाद में सर जाके रखेगा
मैं भी रखूंगा
नहीं अभी नहीं बाद में करना मुश्किल है बहुत बड़ा बात कोई बात नहीं हम बाद में आएगा सर
हाँ ठीक
मिस कॉल करिए
हाँ सर
बाबा बाहर है
हाँ okay, sorry for that when classes happen and at home these things happen anyways. So uh, this is a project for a retaining wall. First of all, what is a retaining wall? uh, this is a wall which is built on the side of the road to protect the road from something falling from the side. Okay, so you may have seen it on the bridges. For example, if you have gone, I was giving the example of the Budaya highway, the main signal under the bridge. Okay, signal with the roundabout. So if you go, you will see that the bridge has a slope under it. Okay, so if you don't give the slope, if you make it a straight, then under the load, whatever you are having under the bridge may fall. Okay, so you build in this case we have the slope, but if you cannot build the slope, then you have to build a retaining wall. Okay, so retaining wall is like let me okay, so this is, you have a road here. Okay, on the side of the road I have maybe a mountain or something. Okay, so along this line I will build a proper wall, a reinforced wall. Okay, so something which comes from this side will not fall on the road itself. Okay, and now the problem is this wall is reinforced, so it has its own weight. It has made up of concrete. Concrete is heavy, and it has steel in it, which is also heavy. But the problem is the site conditions on this site. They have clay in it, and they have high water table. Okay, so there are two problems with the site there: high water table, and the soil is weak, naturally weak. Clay is a weak soil. Okay, and clay, when you put load on it, it displaces. It it moves. Okay, so it's not stable. So now, as an engineer, you have to see, is your design meeting all the technical and legal requirements or not. Okay, but you also have to see if the engineer is showing ethical behavior or not. Okay, so the engineer prepares, or the design firm prepares a design proposal. Okay, and the proposal must meet the budget of the government. Okay, the government has already established a budget for this project, and the budget is very tight. It is a small budget. Okay, engineer is proposing that on this site, because of the soil conditions, because of everything, we should build a steel wall. Okay, which is known as mechanically stabilized earth wall, MSE wall. Okay, in which you have less concrete but more of steel. You don't have concrete, but you have steel. Okay, in high quantity, and the wall will sustain for 50 years. Okay, so this wall meets all the building code requirements. It meets the requirement of the city. They asked for a wall which can sustain the load for 50 years, and technically your calculation shows that it will sustain for 50 years. Okay, but the problem is that on this side you have clay, and you have groundwater. Okay, so this will start damaging the steel wall. When you are doing the calculations, you are not taking these things into account, the water table on the site and so on. You are just doing the calculation on the basis of load and the strength of the material. So that calculation shows that it will last for 50 years. Okay, but you know that because of the site conditions, it will not last for full 50 years. Within 48 years it will start, or it will fail. Okay, if you want to extend it to 50 years, then you have to do extra maintenance. You may have to replace the corroded, or the part of the steel which is damaged. Okay, so calculation says it will last for 50 years, but to last for 50 years it needs extra maintenance cost. Okay, now the budget which the city has given you for construction, you are meeting that, but it will create problem in the future. Okay, so and you are fulfilling all the requirements of the strength and the bearing capacity and the factor of safety, everything. Okay, you are meeting all the technical requirements, but at the same time you are creating a problem for future. Okay, so in this case the wall will get damaged, and then the wall is getting so steel when steel is a flexible material. Okay, so when the steel will start getting damaged, it will start to bend, and you can imagine if there's a wall on the side of the road and the wall is bending, you know what can happen to the road itself. Okay, the wall on the side is bending towards the road. So this is my wall, and this is slightly bending towards the road like this. Not completely like this, but like this curve. Okay, so you can imagine what can happen to the drivers. Okay, because the drivers may go into this bend, and they may have accidents. This bend may be blocking their line of sight, their sight distance, and so on and so forth. And obviously when this bend is happening, nobody will get close to the wall, so the last lane and the shoulder will be useless. Nobody will go close to the bending wall. Okay, now your design will not show these things. Okay, it's not, your calculations are correct, but these are the problems which you will have in future. Okay, so you have selected a system which is fulfilling all the current requirements, fulfilling the budget as well, but it is creating problems in future. Okay, so you are meeting the technical requirements, you are meeting the requirements of the law of the system. Okay, but at the same time you are not fulfilling your ethical responsibility. Okay, and you are hiding something from the client. You are not telling the client, if I go with this system within your budget, it will create problems for the drivers, it will have damage in the wall, it will increase your maintenance cost, and blah blah blah. You are hiding all these things. So you are fulfilling the law, you are fulfilling your professional duty, but you are not fulfilling your ethical duty. Okay, so the ethical responsibilities of the civil engineer are towards the public, and for public, their health and safety comes first. The client, your employer, your own organization. So whenever you are giving an advice to your boss, you should give an honest advice. Okay, you should not hide anything, you should not lie. Okay, usually in something like this, you may, for example, your boss is asking why this project is delayed. Okay, or what can we do on this project to make it go faster. Okay, or what can we, or how we can manage our resources. I have these many people, I have 2-3 projects, how can we manage that. Okay, now your honest advice, okay, I look at these 3 projects, the most important one is project A, but I'm on project C. Okay, so if I'm honest, I will tell the boss, okay, give the resources to that project first and then my project. Okay, but if I'm just looking at my project, I say whatever to make the resources come to me. Okay, but you are at the same time you are being dishonest, you are not being honest. Okay, so this is what we mean. Or the boss is asking you who is the most professional guy in your team, so I want to promote him. Okay, and you give the name of your friend who is sleeping 4 hours out of 8 on the site. So this is being dishonest. Okay, some examples of being dishonest. You have environmental responsibility, we call it environmental stewardship. Okay, so you have to make sure that the resources you are using are sustainable. You don't use any harmful materials which can be harmful for the environment, for the people, for the workers on the site, and so on and so forth. And you have to minimize the long-term harm. Some things, they don't show that much harm in the short term, but in the long term they will create a lot of harm. For example, the equipment which you are using in your building for AC and ventilation. Okay, so it is creating a small noise. Okay, people will not notice it in the short term, but if you know that if this noise if they keep on having this disturbance for 8 hours a day, then this will surely damage their mental stability and so on and so forth. Okay. Similarly, for the road projects, you don't see, the vehicles are moving, you don't see the environmental damage at that moment. You don't see the environment changing when the vehicles are, but in long term, this will damage the environment. So you have to look into the long term environmental damage as well. And you have duty towards your own profession as well. That duty involves maintaining public trust. So when you do your job properly, people think that engineers are trustable people. Okay, we can trust engineers because this guy did his job properly. So when you do your job properly, you are creating a positive image for all the engineers, all the civil engineers. Okay, and acting with integrity, meaning being fair, being honest, and whatever. There was a third thing as well, I forgot. Okay, so let me look at the time. No, we cannot do this. Okay, so I will come back to this activity in the next lecture at the start. Okay, so we have an activity for the next lecture at the start. We have just 15 minutes now. I cannot do it now. Okay, so ethics in everyday life. Okay, how it applies. Reducing safety margins to cut costs. Okay, if you have seen in some of the places where workers are required to wear gloves to do their job. Okay, a lot of times you will see them only wearing gloves on the right hand side, on the right hand, because they are working with their right hand. So they instead of two gloves, they are using one glove, and the other glove can be used by someone else. Okay, or somebody who is just inspecting the site, he is doing it without the safety shoes. Okay, and without gloves and goggles because he is just inspecting the site. Okay, so this is what we mean by reducing safety margin to save your costs. Okay, and there can be bigger examples as well. Okay, ignoring weak soil test results. So you have soil which is weak. The problem with the soil is why it is mentioned here. It will not show in the short term. Usually the problem with the soil doesn't show in the short term. You may construct the whole building and you may not notice any damage to the building or any deflection even after months. Okay, so you have a weak soil report. You need to change your design to meet the soil report, but you don't change it and you go on with the same design. The client will not know that you have a problem for maybe after the construction for maybe 6 months, 8 months. Okay, because the soil does not just collapse. It moves very slowly. It absorbs the impact very slowly. Okay, so you may not see the impact immediately. Okay, signing off on incomplete designs. Signing off means that you are starting the work, the design is still not complete. Sometimes it is a client requirement, so it is clearly written in the agreement that once a design is ready, there can be these changes and we will review the cost, we will review this and that and so on and so forth. Then it's allowed. But normally, you don't just start working to save the time without informing the client. Okay. Using lower quality materials, obviously you will have more maintenance cost in future, you will have less life of the project and so on and so forth. Remaining silent about unsafe practices. So you see the workers are working without helmet. You see they don't have any harness. You see the material which is stored on the site is not stored in a safe manner. It can fall on somebody and so on and so forth. And you don't report it. This is again unethical. Okay, so when you are considering decision making for ethics, you have to ask these questions. First question is, if I keep this thing as it is, who could be harmed? It could be the worker on the site, it could be the person using the facility and so on and so forth. Is the public safe? Will this harm, what you are looking at, is only to a specific person or is it to everybody? Okay, the decision I'm making, is there is some lie involved in it? Am I hiding something? Okay. What I defend this decision publicly. This is accountability, right? This is the aspect of accountability. So if I take this decision, somebody asks me in public that why did you do this? Can I give him or her a safe response, a good response? What will happen if this structure fails? Okay, so now you may say, why would we ask this question? Like, why would we want our structure to fail? Because we know every structure has to fail. There's a life to every structure, right? No, nothing is forever. Only Allah is forever, right? So nothing is forever. So as engineers, we even design the failure of the structure as well. Okay, we even design the failure of the structure as well. Or we look at how it is going to, or how it is supposed to fail. There's a good example I gave you before as well, which is in the reinforced concrete structures. Can someone tell me why we use steel with concrete? What is the reason of using steel with concrete? Yes, Mohammed Jawad. High tension, okay. More strength, okay.
Doctor, because of the cracking that may have it in the concrete, since there is some tensile tension comes to the concrete, and the concrete does not carry any tensile tension. So we put reinforcement with steel, so it's carry this type of loads.
Yes, yes, yes. So all of you have the basic idea. Yes, we are looking for more strength, specifically tension, because concrete is weak in tension. Okay, so yes, you have the idea, but when we are designing this, we know when tension happens in the lower part or the upper part, whatever part of the concrete, there will be cracks. So when, if you are using only concrete, these cracks mean failure. If you are using only concrete, these cracks in the tensile region mean failure. Okay, so the steel is basically used at the failure of concrete. Okay, and the steel gives you the time during the failure of the concrete. Steel gives you extra time during the failure of the concrete. Okay, so this is the whole idea. Very good, you have got the right concept here. So the point was that you are not assuming that the structure will remain safe for the entire 50 years or 100 years. We know after this much time it is supposed to fail. So we look at how it will fail and how can we make this failure safe as well. Okay, so even the failure should be safe as well. The failure should not be that it will suddenly collapse and fall on someone. Okay, so there's the bridge, and the bridge life is 50 years, so after 50 years it will suddenly collapse. Nobody wants that. Okay, so after 50 years what will happen? Yes, you will see the damage in the bridge, so somebody will close it and they will repair it, or they will redesign it, reconstruct it, but it will not fail suddenly. So even the failure is designed. Okay, so how it will help you if you are following ethics, how it will help you in your profession. Okay, so when you are following ethics, you have the moral backing with you. Okay, so you become more confident. Okay, and you are trusting your judgment. You will not be shy, you will not be you will not hide. Okay, you will say your your point with confidence, because ethics gives you moral backing, moral background. Okay, nobody can deny you. If you say this is not good for health or this is not good for safety, nobody can deny you. So it gives you more confidence. Okay, and it will also make you stand firm on your point, because the point you are fighting for is related to public, it's related to future, and so on and so forth. Okay, uh, and then you see why engineering fundamentals are designed. Okay, the things which you are learning in engineering, in ethics you see how they are affecting people's lives. Okay, when you are trying to follow them ethically, so you see the impact of these engineering principles on people's life. If I do this, this will happen to safety, this will happen to uh, to health, and this will happen to the environment, and so on and so forth. Okay, so you see the real examples or the real applications of your engineering principles. Okay, so it's no longer about calculating an answer. That answer could be somebody's life, that answer could be somebody, could cost someone thousands of BDs, and so on and so forth. So in the end, when you are learning the ethics, you are trying to become a responsible professional, not just somebody who is going after the job or going after the promotion. Okay, so I will do whatever the client says, I will do whatever the boss says because I want to be successful. No, in the end, you have to become a responsible professional, because your decisions and your actions will affect others. So ethics bring meaning to your engineering knowledge, real meaning. Okay. Okay. So next lecture, I believe if we will have all activities, inshallah. Okay. So try to join on time. Okay. Again, I will repeat couple of things which I mentioned at the start.